Hello. What follows today is a quick overview of some of the curve sketching concepts that we've been looking at over the last several days. I'm going to try to go quickly on this video, so if I go too fast, make sure you pause if you come across something that you don't understand. Pause, think about it, and see if you can understand. Ask questions if this doesn't make any sense. So for starters, we're going to study this particular graph, and there's 7 points along the graph, and we have to identify which of those points are going to represent various characteristics. Now they talk about function increase, they talk about relative maximum, they talk about slope negative, slope zero, relative minimum, decrease, and slope positive. So basically, whenever they say things about slopes, being positive or negative, they're talking about first derivative, and function increasing or decreasing, they're still talking about first derivative, and relative maximum or minimum, they're talking about first derivative equals zero, slope zero, same thing. So this is just showing you that there's a couple of different ways to describe the same general principle. So in the first case, what I'm going to do, I'll write f of x is increasing, which means f prime of x has to be positive, and when f prime of x is positive, we are talking about points 3 and 7. So in other words, at points 3 and 7, f of x is increasing because the slopes of the tangent lines at points 3 and 7 are positive. Second issue is when or where is their relative maximum. That's going to happen at point 4. And two things have to be happening to be a relative maximum. First of all, you can see in the area it's the highest point in the neighborhood. But furthermore, the tangent line is going to have a zero slope, and the graph is concave down at that point, so we're going to have a negative second derivative. So I say that here when they say at point 4, the first derivative is 0, the second derivative is negative, means that there is a relative max at point 4. F prime of x is less than 0 is basically when they say the slope is negative, they're just looking for what points are on the graph when the graph is decreasing. So that happens at point 1 and it happens at point 5. Part D, slope of 0, that happens at 3 different places. Basically we're looking for stationary points, so you identify all 3 stationary points. Those happen to be points 2, 4, and 6. Next one, relative minimum. To find a relative minimum, we just simply identify concave up, where the graph is going upwards after those stationary points. So those are points 2 and 6. At what point is the function decreasing? Well, that's a redundant question. You see in F when they're saying at which points is the function decreasing, and in part C they said at which points is the slope negative. Well, they're asking the same question in different ways. So the answer to C is the same as the answer to F. Similarly, slope is positive. Well, that's the answer to question A. When is the function increasing? So the lesson here is there's more than one right way to say something about the descriptions of a function and its derivative. Now, we can take information about a graph, whether it's decreasing, f prime of x is less than 0, increasing, f prime of x is greater than 0, concave up, or concave down. If you read this carefully, it says sketch the graph of a single continuous function. So each of these is a description of the same function, and we have to match all those characteristics. So in the first case, I just know that when x is going from negative infinity up to negative 3, or negative 6, right? Sorry, and when x is going from 1 to 3, the function is going to go uphill. So I know that there's a y-intercept at 0, 2, and I know that the function decreases up to the point 6, and between points 1 and 3, the function will decrease in those situations. The second statement I have says that the function is, the derivative is positive, which means the function has to increase from negative 6 to 1 and from 3 to infinity. So I just try to draw a graph where from negative 6 to 1, we have an increase. We also have an increase from 3 to infinity. So these two places are where it's going to increase. You can see decrease, followed by increase, followed by decrease, followed by increase. So I can put these two pieces together and get a sense of the graph, but now I have to verify concavity. So in part 3, it's saying concave up. Only concave up at the left-hand side of the graph, concave up at the right-hand side of the graph. Those are the only two intervals over which we have concave up. Now I have to be careful because here I showed f prime of x increases, but this is concave up increasing, and this is concave down increasing. So I'm going to have to change my purple when I make my final graph. I'm just looking at each of the 4 parts separately. Anyway, part 4 says f double prime of x should be negative, which means they're concave down from x is to -6 all the way up to x equals -3. Now here's up to positive 1, and I can continue being concave down all the way after that maximum point. So what I did was I took all of those graphs and compiled them and make sure that everything fits. So the only thing that's going to be goofy about this graph, it's not going to look like a typical polynomial because, according to the information I was given, we're concave up from here and immediately concave down after there. So the concavity switches. It doesn't have that subtle inflection point. Rather, it just abruptly changes. If you look at all 4 of these descriptors, each should be satisfied by the shape of the curve in each of these locations. Hope that's helpful. Now, before I wrap everything up here, I just want to highlight what's different about number 5 compared to number 1. Number 1, you're given a graph of a function, f of x, and then you have to look at the points and think about the slopes of their tangent lines to answer questions about derivatives. This is slightly different because we are actually given the graph of the derivative. This is f prime of x. So we don't want to confuse that with f of x, and I'll show you how that manifests by the way the questions are asking. It says, for which values of f of x for which values of x does f of x have a horizontal tangent line? If you're not paying attention, you would probably say that x is 2, and when x is 5, we have horizontal tangent lines. So that's true that we have horizontal tangent lines at those 2 values for the derivative. But horizontal tangent lines in the original function have 0 derivatives. So in other words, when the derivative is equal to 0, we have a horizontal tangent line. That happens at 3 different places. When x is negative, ooh, holy cow, that was fast. When x is, I'm sorry, I started off with part B, but I was supposed to be looking at part A. Forgive me. It says, what is the slope of f of x at x equals 2? Again, the temptation would be when x is 2 to go up here and say, oh, the slope is 0 because it looks like a stationary point. But this is the derivative. It's a slope function. If the y value equals 4, it means the slope of the tangent is 4 when x is 2. So remember, this is not the function, this is the derivative. And so I say f prime of 2 is 4, which means when x is 2, the slope of the tangent is 4. Now on to the horizontal tangent line. Again, do not pick the stationary points of the derivative. Rather, you pick the zeros of the derivative, because here, negative derivative means the function's decreasing. Here, positive derivative means the function's increasing, which means we had to stop in order to go from decrease to increase. That happened again. We were increasing, then we were decreasing, and then decreasing, then to increasing. So the stationary points are at -1, 4, and 6. In other words, horizontal tangent lines means f prime of x equals 0, which happens in 3 locations according to the graph. Part C. Part C is asking intervals when the function is increasing, and that's easy enough. All you have to do is find the locations when the function f prime of x is positive. If f prime of x is positive, the function was increasing. So all I have to do is say, well, when x goes from -1 to 4, we have positive derivatives, and from 6 onward. That way I can now tell the relative minimums are going to occur when we go from a decrease to an increase, and that happens twice, at -1 and 6. Relative maximum would occur in the opposite place, where we go from increase then to decrease. We're going up and then down. That means we have a maximum, a relative maximum at x equals 4. We get to f. Is f of x increasing or decreasing at x equals 5? When you find x equals 5, you go down here, and you can see that the value is negative. The value of f prime of x is negative, which means the function is decreasing at x equals 5, because the slope of the tangent line is negative at x equals 5. Part G, concave up or down at x equals 4. So here we see x equals 4. The tangent line is going to be 0, so there's a horizontal, there's a stationary point here, but because we decided already that it's a local maximum, we know that it's going to be concave down, so we know that f prime of 4 is going to be negative. And furthermore, they want to know x values where we have inflection. Inflection points happen when f double prime of x equals 0. In other words, it happens at the maximum or minimum of f prime. So f double prime of x is 0 right here, and f second derivative is 0 here. So that's where we have our possible inflection points. So I hope you found this helpful in some way. Like I said, I was going over it very quickly. Please, most importantly, pay attention to whether you're given information about the slopes of a function or you're given information about the y values of a function. And that is to say, here you have f of x, and in some cases you might be given f prime of x, and your interpretation is different depending on the given information. I do have some more answers to some of the questions that were assigned here. If you freeze the screen, you can see how I answered this question. And similarly here, freeze the screen, and you can see how I answered the remaining questions. These are redundant to some stuff we've already talked about, but if you'd like to get some reinforcement, pause the video and see if there's agreement here. Thanks for listening.